Okay, now we will do some examples, or actually an example of solving a system of equations by graphing. Okay, here are our steps. First, get the equations in slope-intercept form. Identify the slope and y-intercept for each. Graph the lines. Find the point of intersection and check in both original equations. So for this one, pause the video, do these on your own, and then come back and make sure you did it right. Okay, so first thing we do is get the equations in slope-intercept form. That means I want y by itself. For the first equation, I can just subtract x from both sides, and I've got my slope-intercept form. That one was easy. The next one, subtract 2x from both sides. Now I don't have y by itself yet. I need to either divide both sides by -1 or multiply both sides by -1. It's the same thing. So I get y equals 2x plus 5. So step 1, get the equations in slope-intercept form. I'm done. I've got that. Now the slope for the first line. What is the slope for that first line? Slope for the first line is -1. What is the y-intercept? It's also -1. For the second line, slope is 2, y-intercept is 5. So I've identified the slope and the y-intercept. You don't need to write those explicitly if you don't want to, but it really doesn't hurt, and it doesn't take long. Now to graph those, put the intercept on first, down 1/1, and I get that line right there. Put the intercept on first, up 2/1. I get that line right there. So I've graphed each line. Find the point of intersection. Looks like it's that green point right there. That looks like it's the point -2, +1. Now to make sure I did it right, that my graphing was careful enough, I'll plug it into both equations, but do I want to plug it into the slope-intercept forms? Nope, not even if it's easier. Always check in your original equations and always check in both. So we put in the first one, and -2 plus 1 is indeed -1. In the second one, 2 times -2 gives me -4 minus 1 is -5. So the green point is on the red line, the green point is on the blue line, so the green point is the point of intersection. That's where they cross. All right, now what could happen? If we have two lines, will we always be able to find a point where they cross? Do two lines always cross exactly once? Could they cross twice? Think about it. Can two lines cross each other twice? No, they can't cross twice. Could they not cross? Yeah, they can. If they are parallel, they're not going to cross. Can they cross more than once? That's a different question than can they cross twice. Can they cross more than once? Yes, they can. They could cross. If they're right on top of each other, they're crossing all of the time. So our possible outcomes are that our lines cross. Those are the first two examples we did. We just get an answer. Now, if the lines are parallel, they're not going to cross, so there's no solution. If the lines coincide, that means they're right on top of each other, then we have an infinite number of solutions. How do we recognize that? If my lines cross, how do I know right at the get-go that I'm going to have crossing lines? Well, once I put them in slope-intercept form, they will have different slopes. So they will have different m's. If the lines are parallel, how do I know that they're going to be parallel? I can graph them and see if they look parallel, but looking at the equations, how do I know that they're parallel? Well, they'd have the same slopes, but they would have different y-intercepts because they'd cross the y-axis at different places. If the lines coincide, if they're right on top of each other, they're the same line. So they'd have the same slope and the same y-intercept. Now, one thing to note, the infinite number of solutions, back in chapter 2, if we had more than one answer, we said all real numbers. We don't say all real numbers here because that's not what we have. An infinite number of solutions doesn't mean all real numbers. If you think about coinciding lines, they cross at an infinite number of points because they're always crossing, but not every point on the grid is a solution. Only those points that happen to be on the line. There happen to be an infinite number of them, but it's not all real numbers. That's different. Okay, so now we'll solve this system of equations by graphing. Again, my first step is to get the equations in slope-intercept form. That bottom equation is already in slope-intercept form. We only need to mess with the first one. So we'll subtract 4x from both sides. That gives me 2y equals negative 4x plus 6. Not quite there yet. I need to get y by itself, so I divide everything by 2, and I get y equals negative 2x plus 3. Now, I'm going to graph both of these, and I want you to graph both of these, but looking at them right now, what's going to happen? Can you look at those equations and tell me what's going to happen when I do graph those? They look pretty darn identical, don't they? So if we graph the first one, it has a y-intercept of 3 and a slope of negative 2, so I get that blue line right there. Graph the second one, got a y-intercept of 3, slope of negative 2, it's right on top of it. How many times are they crossing? A whole lot of times. They're always crossing, so we have an infinite number of solutions. Okay, let's do another. Here's your equations. Pause the video and do this one on your own. Okay, now that you've got it done, first thing you want to do is get the equations in slope-intercept form. For the top equation, I'll subtract x from both sides. Yeah, I don't have y by itself yet, but I'm close. Divide both sides by negative 1, so I get y equals x minus 4, and that guy's in slope-intercept form. Let's get the next one. Okay, I've almost got y by itself. I have to divide everybody by 3. So divide 3y by 3 and I get y. Divide 3x by 3 and I get x. Divide 6 by 3 and I get 2. Now again, I want you to graph these, but look at them. Try to anticipate what's going to happen. What do you notice about those lines? Okay, they both have a slope of 1, and they have different y-intercepts. What's going to happen when I graph? Well, a good guess would be that they'll be parallel. Let's see. So, intercept of negative 4, slope of 1. Intercept of 2, slope of 1. They are parallel. How many times do they cross? Never. So there's no solution. Okay, this is a question that I won't ever ask you to do on an exam, I promise. I just think it's fun. And it was like one of the few real life things that I could think of. This was a problem that was on my kids' Nintendo game. So there is a much easier way to do it, and I'm happy to tell you what that is. But let's just do it the hard way first, because I think being a math geek, I always think of the hard way first. And this is the way when my kids came to me and tried to figure it out, this is the way we did it. So we have a boy and his big sister are talking. The boy says, "If you subtract 2 years from my age and add it to your age, you will be twice as old as me." "Yes," replies the girl, "but if you give me 1 more year on top of that, I will be 3 times your age." How old are they? Okay, well, let's put this into an equation if we can. We'll let G be the girl's age and B be the boy's age. Again, I won't ask you to model this. Just look at the equation and see if you can see why it makes sense. The boy says if you subtract 2 years from my age, that's why we have the B minus 2. And add it to your age, so that's why we have the G plus 2. He says if he does that, then the girl will be twice as old as the boy, so that's why the boy's age is multiplied by 2. So the first sentence gives us our first equation. Then the girl's response gives us our second equation. "Yes," replies the girl, "but if you give me 1 more year on top of that, I'll be 3 times your age." So instead of taking 2 years away from the boy's age, we take 3 years away. We give the girl the extra year, and then she's 3 times as old. Again, don't obsess about getting these equations. I just want it to make sense in hindsight. You don't have to come up with them. So if I want to graph these, I need to get it in slope-intercept form. I'll let G be y, just because it's a little easier. So we got G by itself on the first one, get G by itself on the second one. So to graph these, I've got a slope and an intercept, so let's put those on. And a slope, intercept, and a slope. Where are they crossing? Right there. So how old are these kids? Very nice. That point is 6, 6. So they are both 6 years old. Now the easy way to do it is, since the girl is twice the boy's age, we know that her age is divisible by 2. And since the girl is 3 times the boy's age, we know her age is divisible by 3. Therefore, her age is divisible by 6. So you'd have to see, does 6 years old work? Does 12 years old work? Does 18 years old work? And obviously the first one works. So that's the shortcut, but I didn't see the shortcut until I'd done it the hard way. So that is just an example that's just kind of for fun. And that is the end of solving systems of equations by graphing.